Go. Alrighty. 11.3 notes. The first one is just review, nothing new in number 1. But number 1 is really important for number 2. So here we go. Number 1, GK, which is a segment. I'm going to draw it really long. GK bisects angle FGH. Let me draw angle FGH. Doesn't it look like it's bisecting it, cutting it into 2? So I want you to give the 2 angles that match matching symbols. They told us it was bisected, it was cut into 2, so we say, okay, these match. Let's write about that. We cannot call that angle G, because there's a lot of angle G's. Your options again are, you can call it with 3 letters, you can call it angle FGK, or let's just call it 1 and 2. Angle 1 congruent to angle 2. I can't say given. Did it say up here, number 1, given angle 1 congruent to 2? No. What are we going to say? Yeah, I'm going to say angle FGH was bisected. Or you could write something similar to that. That's how I know 1 was the same as 2. All right, the information says GK bisects this angle, took care of that. It is also bisecting or cutting angle FKH. Let me highlight that angle. FKH. So mark that into 2 equal angles. Oops. We cannot call it angle 1 or 2. We can also not call it angle K. The choices are pick 3 letters to identify the angle, or let's go with the 3 and a 4. Sorry, mine's a little hard to read. I don't have much space there. Try to be neat. I'll try to do it again if I can. 3, 4. Angle 3. Angle 4. How did we know those were the same? Angle FKH was bisected. So we have 2 sets of angles so far. When we look at our picture, there should be something that jumps out to us that we've seen a number of times, and that is reflexive. You notice that they have an overlapping side. This is again how we write reflexive. What side? KG from the top triangle matches KG from the bottom triangle. Is that enough information to prove the triangles are congruent? Yes. So we take all 3 statements, put them together to say triangle KFG congruent to triangle KHG. Put it in the correct order. Were you the first day?
No, I was just.
Oh, yeah, so this page here, this is kind of the part that might be confusing. These are things that prove triangles are congruent if they have 3 sides in common. 2 angles with sides in common. Those are congruent. So if you look up that triangle there, see how I have 2 angles marked the same, and the side between them is the same? That's this. Because we met one of these. That's kind of where those letters are. All right, so we have two angles and a side in the middle. Any questions on one before we use one to do two? Number two, this is the only new part for today's lesson. Number two, GK bisects the same angle. So I'm given the same information. Here, I'm not justifying the triangles are the same. I already did that. Now I'm justifying that side FG is congruent to side HG. Please set your pencils down so I can explain something. Back in number one, would it have been okay to say, when I look at these, I think KF is the same as KH. I'm going to mark them the same. Is that allowed? No. The only things that are allowed is what they give you, vertical and reflexive. So we can't just say, yeah, they look alike. They're the same. However, once we come up with this statement, isn't it true that angle K is congruent to K, angle F is congruent to H? Remember that stuff from the very first day? If I know the order, I know everything that goes with it. So look what's happening here. Where is FG? Is that in the same place as HG? It is, right? So don't they have to be the same? So pick up your pencil. And we're not going to rewrite number one. We should because it's part of the answer. But we're going to take everything from number one. And because of this statement, we're going to say, here's what we know. We know that FG is in the same place as HG, so they have to be the same. FG congruent to HG. My reason, I just kind of explain it in words. I say they are corresponding parts in congruent triangles, meaning they're in the same place, so they've got to be the same. They are corresponding parts. They are corresponding parts in congruent triangles. Which means, again, they're sitting in the same place, so they've got to be the same. So from now on, when it says justify that two sides are alike or two angles are alike, you will do what you've been doing, get the triangles to be congruent, and then hopefully the thing you're looking for is in the same spot, corresponding position. Let's try another one. Number 3. Let's start with our given. Given, everybody go ahead and mark this in your picture and write a statement about it. And they don't really order either.
No, I see some definite reordering of them.
I can say given because it was right there in a statement told to me. Next statement. E is the midpoint of AD. So everybody look at where AD is. Here's AD. And they said E is the exact middle. So what are they trying to tell me with that? Yep, so what two parts have to be the same? More letters than that. Doesn't it mean this matches this? Right? If it's the middle, the two sides match. Good. So I'm going to mark it with a different color. That if E is the middle, then AE is the same as ED. Can I write given? No, because in the given up here, it never said AE congruent to ED. We can say E is the middle of AD. That's how we knew. Now you should see something familiar that you can write about. Vertical reflexive, one of those is there. Is vertical, angle 1 is congruent to angle 2. So Lily, to help you with the letters that we've been talking about, I always tell the students to cover up one triangle so you're not looking at a ton of things that are marked. And then ask yourself, what do I have 2 of? See how I have 2 sides with marks on them? So you would write, and this third thing is this angle, and it's touching both. So that's why the angle goes in the middle, because this angle is actually in the middle of both sides. All right, so we're going to combine these statements to say our triangles are congruent. Let me help you with the order. We got to get the order right. Luke, name the left triangle any order you want. ABE? I only heard AB, but I'm going to go ABE. You are allowed to name the first triangle in any order you want. Now, what goes with angle A? Please look up here. I'm going to do some extra markings in my picture. Maybe you don't want to keep yours nice and neat. Sometimes students say this. Please look at the board. They say A has to go with C because they're both on the top. Well, let's look. A, look at what I call the landmarks. What is it by? A is touching a side that has no marks and a side that has 2 marks. Is that true for angle C? No. Is that true for angle D? Yes. D is touching the side with no markings and 2 markings. Therefore, A and D match up. So in my writing here, A was first, then D is first. Let's do it with the next one. He chose B next. Angle B. Look at what B is next to. It has a side with no marks and a side with 1. What also matches up with that? C. Yep. C is next. Hopefully the third one works, which it does. E was the vertical angle in both. Thank you. Our triangles are congruent. They are by side angle side. Let's look at what we're really trying to show. AB. Is AB in the same corresponding place that DC is? Yeah. So we only have one statement left to say. You can put it below, wherever. We know AB is congruent to DC. How did I know? Well, these dots tell me, but I can't just say these dots tell me. I say their corresponding parts. Incongruent triangles. I'll read it again in case you can't see that. They are corresponding parts. Incongruent triangles. Questions on that one? So it's just one extra step. Prove they're congruent, and hopefully the sides or angles are in the same place. Jackson, did I go too fast on that one?
No.
Okay. All right, last one. Unfortunately, these will probably not be your guys' favorite, but there won't be very many of them. Number 4. You are given the graph. Justify the triangles are congruent. What do you notice? A common thing right away. Reflexive. Let's draw reflexive. They share the side. You could set your pencil down once you're done with reflexive. I'm going to kind of give you an overview of this problem, and then we'll do it together. We have one set of sides. There are things you can do to try to get more angles and sides. I'm going to show you what I think most students do. It's the easiest. You're going to really remember one step. We're going to talk about distance. So don't write this yet. What we're going to do is we are going to find this distance. How long is this side? Then we're going to find this distance, and hopefully they're the same. We will then find how long this distance is and this one, and hopefully they're the same. And if they are, we've got 3 sides that match up. Let me remind you how we find distance. This was activity 5-2, I believe. Let's say I had the point 5, 7, and the point -3, 2. Back in activity 5, I said, hey, let's do distance. There's 2 ways to do distance. Distance formula. Was that anybody's top choice? Was distance formula? I think so. Do you guys remember the other way to find distance without the long distance formula? What do you think? Starts with a P. It's a very smart guy's theorem. He has a funny last name. Yeah, say it louder. Pythagorean theorem. So watch how I do this so that we can do the one we're working on in class. Pythagorean theorem is what we use. We say, if I have 2 points and I'd like to know how far apart they are, I use the Pythagorean theorem, which works like this. I'm going to figure out this. Everybody's watching but not really writing. I'm going to figure out this distance, the x distance. How far apart is 5 from -3? 8. How far apart is the number 7 and 2? 5. Pythagorean theorem says a squared plus b squared equals c squared. And then I go through and use my calculator if I need for that. That's what we're going to be working on. We're going to use the Pythagorean theorem to find the distance between 2 points. So pick up your pencil. I'm going to do my work neatly over here and then try to keep my statements on the left. So maybe below the picture, I'd like you to write AB. We'll find that distance, and hopefully it's the same as the distance from C to D. In the x direction, from 0 to 2, how far are those apart? 2. The y's, one of them is at 1, one of them is at 5. Those are 4 apart. A squared plus b squared equals c squared. We know what this is without a calculator. 2 squared is 4. 4 squared is 16. So that's 20. We'll square root both sides. I'm going a little faster because you've already learned it. If you forget, you can refresh your memory in activity 5. Anybody tell me a perfect square that goes into 20? Yeah, very good. 4 and 5. We simplify. The square root of 4 is exactly 2. Root 5 does not simplify. So this means the distance from A to B, we can't use a decimal unless it's a word problem. So the distance from A to B is 2 root 5. Oh, that took a long time. I'm going to do it 4 times. I'll show you. There is going to be a shortcut here. Let's look at CD. 4 and 6, 2 apart. 2 and 6, 4 apart. If this top line matches this top line, won't the bottom line match the bottom line? You may skip all the in between and just say, I'm also going to get 2 root 5. You need to do the top line, and then you can skip all the extra work. So we've just figured out that both of these sides have a length or distance of 2 root 5. Does that make them congruent sides? Yeah, because they're both the same length. So neatly here in my statements, I'm going to say AB is congruent to CD. Anybody want to guess on the reason I'm going to write how I knew they were the same? Weren't they both 2 root 5? I'm going to write that. Both are 2 root 5. I'm just stating how long they both are. Can you see what you're going to need to do next to complete this? I'll kind of run through it and let you work on it. You are going to find the distance of AD. That should match up with BC, and you should get a little shortcut. Hopefully they're the same. Go ahead and work on those. I'm going to erase my work. I'm going to find the distance from A to D and also B to C. Okay. We should connect them to make them look like ghosts for Halloween. Wait. Estelle's good at drawing. Can you make your circle look like a ghost so I can copy it? Oh, yes. Okay. I'm going to do that from now on. Till Halloween. Did you guys get root 17? Okay. If you've got that, you can go ahead and make this statement. AD is the same or congruent to BC. Put them all together to say triangles are congruent just making it a little festive. That's a terrible ghost, though.